Today we're going to consider this example problem in which we have a population of a total of 80 individuals. Of the 80, 20 have a rare disease. Apparently it's not so rare, but we'll get over that. A random sample of 10 is obtained from the population of 80, and we want to know what's the probability exactly 2 individuals from this sample of 10 have the disease. Well, here my random variable x is going to be the number of individuals with the disease. Okay. I'm asked here the probability x is equal to exactly 2. I'm going to use the rules of probability to calculate this, and probability says it's the number of ways to obtain 2 individuals with the disease. Okay. So remember, there are 10 people being sampled. So if there are 2 individuals with the disease, that must mean there are 8 individuals without the disease. Okay. So number of ways to obtain 8 individuals without the disease divided by the total number of outcomes. Okay, so here the number of ways to obtain 2 individuals with the disease. Well, remember there are 20 individuals that have the disease. We just need to obtain 2 of them. It doesn't matter whether they're first or second. All that matters is that we obtain 2 individuals with the disease. So what I'm telling you is order doesn't matter, and I want to, from 20, I want to select 2 without regard to order. So it's a combination. I multiplied there because of the general counting principle. So it's going to be times the number of ways to obtain 8 individuals without the disease. Okay, so this again, it doesn't matter in which order you're obtained. All that matters is that we obtain 8 individuals without the disease. The population of 80 has 20 with a rare disease, so that's going to be 60 without disease, and I need to obtain 8 of them. The total number of outcomes, I'm sampling 10 individuals, and I want to know the total number of ways I can sample 10 individuals out of 80. I don't care about the order, so that's going to be 80, choose 10, and that's the probability. So this is called the hypergeometric distribution. Okay. Okay. And I didn't use a formula to calculate this probability. That's how I normally do these calculations. But if I wanted to calculate the probability that there are individuals with a trait or a disease, this is how it's going to work. excuse me, and let's not use R there. Let's call this X. So I'm going to just write down here um, that here I'm using R is 20. Okay. The total population size here is 80. Okay. And the sample size I'm going to call little n. Okay. If I do this and instead of using 20, I use R for the number with the trait, which is being the disease, then this is R choose X, where X is 2 here, times the population size. We subtract the number of individuals with the trait, and we use the sample size minus the number of individuals with the trait. That's how many who do not have the trait. And the total number of ways to sample this is big N, choose the sample size. Okay, so that that is the formula for the hypergeometric distribution, and it's being applied to this specific case. So anytime we have to count things like this, where X is the number of individuals with the trait, you could think of that as the success, and we have a population size of capital N and a subpopulation of R with the trait, we can use the hypergeometric distribution to calculate probabilities. Notice we do not have a probability P of success given in this instance. Okay, thank you very much.